record. Maximum power transfer in an RLC series circuit. So we know the formulas for power, right? Everyone, do you remember this thing? P average is basically equals to what?
E naught I
PRMS
naught.
IRMS into cos phi.
Yes, sir.
Yes. So we can write this thing also as I square RMS into R. Yes or no? There are some
Yes,
other
sir.
formulas. Yeah. For example, if can I write this thing as IRMS as ERMS as if I want to write in terms of Z, then cos phi, let cos phi be as it is, and if I write ERMS, I can write it as IRMS into Z,
Z.
right? So basically, this ERMS, this IRMS, and this IRMS will get multiplied. It will become I square RMS into Z into cos phi. So this is also one of the formula. You can rearrange according to whatever the variables are. Similarly, one more you can write E square RMS divided by Z into cos phi. So you can manipulate this formula. These are the main formulas, and you can have these substituted formulas as well. Now, the question comes, when is the maximum power transfer? So please write down a note. Maximum power is transferred to the circuit by the source in an LCR series circuit only when the impedance is purely resistive. When the impedance is purely resistive, then only the maximum power is transferred. So that implies the effect of the inductor and the capacitor, basically L and C, are nullified by adjusting their values. So basically, there can be one particular condition where XC and XL, that particular thing, they both are acting in the opposite directions, right? The phasors, yes or no? So if I can, get such a value of frequency so that, the XC and XL becomes equal to what? XC and XL should become equal. So when this happens, then you can write Z is equal to under root of R square plus XC minus XL whole square, right? So can you see from there, Z will be equals to R? Yes or no? So basically at this particular condition, the impedance is purely resistive. If the impedance is purely resistive, can you see at every other time when XC minus XL or XL minus XC will be something, Z will increase, right? If Z will increase, can we say this particular thing IRMS will decrease, right? Yes or no? So since this Z, whatever Z is equals to R, this is basically the minimum possible value of impedance. Z equals to R is basically what? The minimum possible value of impedance. So at that instant, can I say IRMS or I naught जो होगा वो maximum possible हो जाएगा? this clear? Can you see if the resistance is minimum, then automatically the current becomes maximum, right? Yes or no? Yes or no?
Yes, sir.
So at this point, when the current becomes maximum, automatically, do you remember the average power, which was equals to what? I square RMS into R, right? This also becomes maximum. So you understood this particular thing, guys? How exactly the power is becoming maximum. At this particular condition, the impedance is becoming minimum. Due to the impedance becoming minimum, the current in the circuit is maximum, and hence the average power is also maximum. Is this clear? Is this clear, guys?
Yes, sir.
So this is one point. You can write the second point. The average power consumed. Average power consumed in an inductor or a capacitor. Do you remember we already discussed this point? In an inductor or a capacitor over a full cycle is how much? Do you remember this average power? In the last class we did is 0, right? Yes or no? So hence you can write it over here is 0. So only the resistor consumes the power and loss of energy happens in it, as it does not have the ability to, as resistor does not have an the ability to what? Have the ability
to store.
Exactly, ability to store energy. Whereas inductor and capacitor, they have a capacity to store energy. Yes or no? Capacitor stores in electric field energy, in the form of electric field energy, and that stores in the form of. Is this clear? Is this clear, guys?
Yes, sir.
Now one more thing. The current through a pure inductor. So current which is flowing in the case of a pure inductor or a pure capacitor circuit dissipates no power, right? Ye clear hai, guys? If it does not dissipate any power, so that's why this current is called as idle current, or you might have heard this thing, waterless current.
Yes, sir.
And your school I think you might have done this waterless current, right?
Yes, sir.
Yes, sir.
So since you don't have any the power is not dissipated across the inductor or the capacitor, that's the reason. That's why the inductor and the capacitor are most suitable for controlling the current in an AC circuit. So in spite of using a resistor, you can use an inductor or a capacitor to control the current. Sir, why can't we use a resistor? Because unnecessary addition of resistor what will do? It will consume more power, right? Ayana?
Yes, sir.
So that's why. Okay. So sir, what is this waterless current you're talking about? बिल्कुल बताते हैं. The suppose if this is the phasors, I'll draw again. Let's say this is where the ERMS is acting, and let's say IRMS is acting at an angle of, at a phase difference of phi, right? So can you see over here? I can, I can do two things, guys. I can do two things in this, right? What are those two things? I can resolve this phasor. Can I resolve this phasor into two components? Can you see one component of this particular thing? And similarly, can you see another component? So can you see two components? One is basically IRMS cos phi, and this is IRMS sin phi. Yes or no, guys? Yes or no, guys?
Yes, sir.
And now can you see over here this ERMS and this IRMS cos phi, they are in the same phase. So hence this component will contribute to power. Do you remember P average is basically equals to what? ERMS IRMS cos phi, right? So can you see this component, it contributes to the power, right? Hai na? Yes or no, guys? But can you see this component? This component is basically not contributing anything towards power, hence this component of current is basically called as the wattless. Okay, is this clear, guys? Ek minute.
Yes, sir.
Yes, sir.
Right, please write.
So could you explain this once again?
Hello. So this, हाँ बोलो बेटा, क्या बोल रहे थे? You were saying something?
Part again.
What?
Can you explain this part again?
Okay.
The third.
This part?
Yes, sir.
See, whenever you have a pure inductor and a pure capacitor, we just learned this particular thing in the last class as well. I made you write this particular thing as well. Okay, whenever you have an inductor or a capacitor, there is no power dissipated across it, right? Over a full cycle, the average power is zero. We proved it also in the last class with the help of cos phi, right? Power factor. Yaad hai?
Yes, sir. Yes, sir.
So basically, in this particular case, this inductor and capacitor, they do not dissipate any particular thing. So that's why, this current which passes through the inductor and capacitor, it does not depend, it does not dissipate any power. So that's why we name it as wattless. What means power? And power is powerless current. So since the current which passes through inductor and capacitor is not producing any power, that is why इसका नाम दिया हमने, we named it as wattless current. Okay, and
Yes.
इसीलिए in spite of adding another resistance to the circuit, we try to change the inductor and capacitor so that we can vary XL and XC without involving any further loss of energy. Are you getting my
Yes.
point? So
Yes.
changing the inductor and capacitor is much more easy. So hence, when we change the inductor and capacitor, automatically XL and XC will get changed, and automatically the Z will change accordingly. And if Z will change, automatically current can be controlled, right?
Yes, sir.
So that is why I wrote that inductor and capacitor, they are most suitable for controlling the current in an AC circuit. And here in this diagram, we drew what? This E equals to E naught sin omega t. So I drew the RMS phasor, and here also the current phasor. Can you see the angle between them is basically phi? The phase difference is phi, right? If the
Yes,
phase
sir.
difference is phi, I can resolve this IRMS into two components. One is IRMS cos phi and one is IRMS sin phi. And we know the power formula. Average power is basically ERMS into R IRMS into cos phi, right? So basically, can you see this component IRMS into cos phi? This is basically that component which will contribute to the power. Whereas this
Yes,
IRMS sin phi does not contribute anything. Hence, this thing is called as the wattless current. If someone says that the wattless current in an wattless current in an RLC series circuit is basically how much? Whatever it is given. So basically, that will be IRMS.
fine, fine.
Is this clear?
Yes, sir. Thank you, sir.
Okay, no problem. Shall I give you problems based on this now? I'll not give that many problems in this thing. थोड़े बहुत. Shall I give it? इशिता, पेपर कैसा था? How was the paper? Long time no see.
Yes, so I think it went well, but it was really like time pressurizing.
Obviously, online paper इतने time बाद offline की the practice has left. And by the way, don't worry guys, I'll take your subjective test as well, है ना? Don't think like I won't be taking your subjective test. Subjective test will be there, but they will be when your school exams will be near. So at that time, I'll be giving you lots of subjective tests as well. Also in the class itself, we'll do some subjective tests. Okay. So don't worry about कि sir subjective test we are not doing, subjective test we are not doing. We will do it. Don't worry. But first, because in January you have the first attempt of JEE, right? And after that, we generally do the school portion. So that what happens ki January attempt is done, then school portion is done, then again JEE mains is there, and then JEE advance is there. So the whole curriculum is there like this. So thoda sa I know, some people might feel like sir we are not doing any writing practice, but I think I am covering each and everything which is there in your syllabus. Okay, I am teaching you extra only. Don't worry. Lots of things are there which are not there, but still I am teaching you. But anyways, question. The potential difference E, the potential difference E and current I flowing through an AC series circuit is given by E is equals to 5 cos of omega t minus pi by, and the current is given by 10 sine omega t. Now the question is, find the average power dissipated. And I think most of the people will do some mistake in this. Please remember, when we derived the formulas for average power, do you remember both were in sine? E was also E naught sine omega t plus something, and I was also I naught omega t plus something, right? Sine. Both were sine. So basically, remember this fact: whenever this is given cos, then you need to convert it to sine, and you know how to do it. And it will be much more easier if you try to draw the phasor for this. Can you see, guys? E cos omega t pi by 6. So for example, if I talk about at t equals to 0, can anyone cos omega, guys, cos minus pi by 6. So whenever it is cos, that implies the phasor will be over here. Yes or no? And can you see minus pi by 6, that implies you need to do pi by 6 clockwise, right? You need to shift this phasor pi by 6 clockwise, yes or no? Pi by 6 is how much? Can anyone tell me? What is
30.
pi by 6? 30 degree, right? So basically the phasor is over here. This phasor, E. E naught is over here, right? Current is over here, right? Is current over here? So can anyone tell me what is the angle between them? Can you see over here? Phi was basically the phase difference by which the current was leading. So can you see here the current is lagging by a phase difference of how much? 60 degree. So you have to analyze this thing based on, you know, this function. Now you understood how to exactly to analyze. If it is cos, then you don't start from here, you start from here. And since it is minus pi by 6 given, so basically I have rotated it clockwise pi by 6. If it was plus pi by 6, then I would rotate it anti-clockwise 30 degree, right? Guys, are you understanding how to deal with phasors and all? Everyone? दर्शना, श्रीष्मा, phasor समझ में आया?
Yes, sir.
पक्का?
Yes, sir.
Because this phasor will help you in SHM as well. Is it clear? Most of the chapters which are there in 12th grade, if you learn them very easily, then 11th grade topic becomes easier. For example, if you learn this thing, the collision momentum thing, do you remember collision and all? ये याद है किसी को collision chapter, elastic collision and all? So if you remember
Yes, sir.
collision, then your dual nature of particles में एक segment becomes clear. If you learn electrostatics well, then electrostatics and circular motion, then modern physics. उसके बाद में modern physics में भी atomic structure and nuclei. Okay. Then if you do wave optics over here in grade 12th, then the waves which is there in grade 11th, that gets clear. When you do this chapter, alternating current, your simple harmonic motion gets prepared. Are you getting my point, guys? So it's not necessary that, sir, I have missed 11th, that you know, so that's what do we call it? What do we call it? You know, that's a burden. क्या बोलते हैं उसको? Burden बोलते हैं, क्या बोलते हैं? Setback. Yes, that's a setback for you. No. If you have not learned anything in 11th grade, it's okay. Even learning from 12th grade will help you to, you know, doing things from 11th grade. Okay, I am there to tell you how exactly things will change. Rest everything you need to do. Okay. So I think everyone is clear about this phasors and all, right? Yes or no? So I can write the phase difference between them. This is your E naught and this is your I naught. The phase difference phi between them is minus pi by 3, right? Yes or no? Phase difference is minus pi by 3, right? People बोलते भी नहीं हो यार.
Yes, sir.
The average power is basically IRMS, ERMS, or since IRMS, ERMS is not given to you, so E naught, I naught. I think you can do it now easily. एक और trick बताओ. Shall I give you one more trick? Which is applicable है ना? Which is मतलब workable. I equals to I naught. I'm not given the value of I naught, right? Oh, I naught is 10. Sorry, I miswrote this thing. It's 10. Okay. One more trick I'm teaching you. देखो. 10 sine omega t. Are you aware of this format? Are you aware of this format? Do you like this format? Do you like this format which we learned? E equals to sine omega t and I equals to I naught sine omega t plus pi, right? which format do you love? Do you love this random format or do you love this standard one?
Standard one.
तो फिर
Standard.
देखो,
Standard.
अब देखो है ना, एक चीज सिखा रहा हूँ. First of all, you can do this thing है ना, कभी भी if you want to increase or decrease the phase, so basically phase, by phase I mean basically the angle, right? Yes or no? So by rotating the whole thing, if I open my video, wait a second. Suppose this is E naught, I naught, है ना? E naught, I naught. Okay. The phase difference between them is how much? Pi, right? But we are always aware of having E naught to which format? We either know cos omega t, we either know sin omega t. This beach wala thing is very confusing. Sin omega t plus phi or cos omega t plus phi, right? So can you see over here? Can I rotate this whole thing like this or like this? Can I rotate it like this? Are you able to see this?
Yes, sir.
Can I
Yes.
rotate these phasors like this in such a way that, can you see, EMF became how much? Straight, मतलब cos omega t.
Yeah.
And
Yes, sir.
similarly, can I do it like this so that EMF can become sin omega t as well? But can you see, I'm not changing the angle between them. I'm just rotating the phasors in such a way that which is convenient for me, right? So I can convert this to either this, or I can convert this to either this. Everyone clear? The same thing,
Yes,
this
sir.
concept which I taught you, mathematically can be done like this. Can you see? If this was like this, I want this to come over here, or I want this E naught to go over there, enough. So let's try to make E naught go over there. Now tell me this particular thing. This is omega t minus pi by 6, right? If I want to make it omega t, then what shall I do? I need to add plus pi by 6 in this, right? Yes or no? So if I
Yes, sir.
rotate this phasor by a phase of plus pi by 6, then I need to rotate this phasor also by plus pi by 6, right?
Yes, sir.
So this omega t minus pi by 6, if I want to write it in this format, then this I have to write it as are you getting my point? So basically, can you see the concept which I told you, rotating both the vectors by same angle? So can you see plus pi by 6 plus pi by 6? दोनों जगह पे I have added plus pi by 6 so that the first thing becomes this and the second thing becomes this. Now, if it is cos omega t, then you know how to write it very easily. You can write it as 5 of sine omega t plus 90 degree, right? So this is 90, this is 30. So what is the phase difference between them? What is the phase difference between them? This is 90, this is 30. तो phase difference कितना हुआ इन दोनों के बीच में?
60.
60, and that too, can you see, current is lagging because इसका बेचारे का 30 only है and this is 90. So EMF is leading according to our convention, that is negative. So can you see, from mathematically also you can apply this thing. Is this clear?
Yes, sir.
ठीक. So remember this you can do in SHM as well. It's not necessary only EC. So anyways, when you will calculate the whole thing, your answer will come to be 12.5 watts. Anyways, next question. Coil homework है ना, has inductance 2.2 by pi Henry and is joined in series with a resistance of 220 ohm and AC EMF of 220 volt at 50 hertz is applied. Now question is find the wattless current. Okay. So basically what is there? Either you can go with the conventional approach, wattless current is equals to IRMS into sine phi, right? So you can just find out the value of phi, you can find out the value of IRMS and you can just put it answer, right? Yes or no? But in spite of finding IRMS and all, phi's value can be find out using impedance triangle as well, if you remember. Is it the impedance triangle? So the value of phi can be find
Yes,
out
sir.
using impedance triangle also. So try to do this question as a homework. The answer to this question will be 0.5 ampere. Next question. Please write. Give you next. So the questions on AC will be easy. Ishita, by the way, have you seen all the video lectures which I was giving in the group when you were absent?
No, sir, I haven't watched them yet.
तो बेटा ये कब करेगी? इतने सारे कम से कम 5 या 6 लेक्चर हो गए.
Yeah, sir, I had an exam yesterday, like my
Hmm.
entrance, and I
तो
finished
फिर
that.
कल tomorrow is Sunday. I'm not
Yeah,
tomorrow नहीं, sorry. The day after
Saturday.
is basically what? Sunday, right? So I've not kept any extra classes on
Yeah,
Sunday this time.
Sunday,
This Sunday
Sunday
I've not
club.
kept any extra classes. Maybe next Sunday I'll keep. है ना? So it will be your job to at least see the videos. As easy circuit is easy. है ना? If you might have learned it from school, right?
Yeah,
A
yeah.
little
So I'll
things
watch
extra is there, so try to read through it and do one thing, try to read through the notes first and then see the lecture. Okay,
Okay,
time bachega thoda. If you can't understand anything, then see the lecture, that part only.
okay, sir.
And also the numericals, whatever
Yes,
numericals we discussed, no, that you need to do it again.
yes,
Question
sir.
dekh ke, concept seekh ke, you need to do it again. So there is a question given in an AC circuit, EMF is this much, current is this much, and we need to identify what is the power dissipated in the circuit. Okay, easy question hai, ho jana chahiye. Chal. With this thing, I'm done with this particular part of power. Now let's discuss the next heading, which is called as resonance in an LCR circuit.
So what's the answer for this question?
The answer for this is 0 watts.
So can you scroll up a little bit?
Sure. Acha, do one thing, just note it down. I'll be back in 2 minutes. Shall I scroll more? Okay, fine. Okay. I'll be back. Give me 2 minutes. Guys, shall we start? So suppose you have an LCR series circuit and let's me give you okay. So you have an RLC series circuit and E equals to E naught sine omega t. So we know that the impedance in the circuit is given by under root of R square plus XC minus XL whole square, right? And tan phi is given by XC minus XL divided by R. एक second. So tan phi is equals to XC minus XL divided by R. Now see this particular thing over here. I'll write the current as well. I equals to I naught sine omega t plus phi. Anyways, so we know this particular thing. There will be, suppose if this source, we can vary the frequency. If it's a variable frequency source, variable frequency AC source, that implies frequency can be changed, right? Yes or no? Can the frequency change? Yes or no, guys? If I can change the frequency, that implies I can change the, hello
Yes, sir.
guys, can you hear me now? I think my connection broke.
Yeah.
Something happened. So till where did you hear? Guys, you heard till where? Till the circuit, right? So suppose, guys,
Yes.
if this source which I have, this alternating EMF source, if I have this source of variable frequency, what do you mean by variable frequency? I can turn on any knob and due to which I can vary the frequency of this source. Then I can say if frequency can change, then automatically omega can change, right? If omega can be changed, then can I say this particular thing XC and XL can be changed, right? Can I say this? Yes or no? Can I say this? Yes or no? Simple सी बात है. If I change the frequency, omega changes, and if omega changes, then XC and XL can be changed because XC and XL both depends upon omega, right?
Yeah. Yes, sir.
So we know this fact as well. So if XC and XL can get changed, then can I say this particular thing at one particular frequency? At one particular frequency, which is called as resonant frequency. At one particular frequency, the value of f, let's say f, if I give it an symbol f naught, okay. So at one particular frequency called as f naught, which is resonant frequency, when f is equals to f naught, omega is equals to omega naught, which is basically 2 pi f naught, right? Yes or no? So at this particular instant, xc will be equals to what? Omega naught into L, and xl, sorry, ulta लिख दिया मैंने. Xc will be 1 upon omega naught into C, and xl equals to omega naught into L. I can make at this frequency, I can make xc and xl equal. So when I make this particular xc and xl equal, you know what is the consequence of this particular thing? At this particular time, the component z becomes r. Yes or no? So can you see this is the minimum possible value? I think we already discussed this, right? So at when this happens, z becomes minimum. When z becomes minimum, the current becomes IRMS becomes maximum, and also the power becomes maximum. Yes or no? So at one particular frequency, at f equals to f naught, xc equals to xl, and at this particular thing, maximum power will be, oh sorry, a maximum power will be transferred. Is this clear? This condition at f equals to f naught, xc equals to xn, and power becomes, z becomes minimum and power becomes maximum. This condition is called as resonance. That implies at this particular frequency, xc and xl will resonate with each other, and they will behave in such a way that both will cancel out or nullify each other's effect. So they will resonate in an opposite direction, due to which what will happen, they will cancel out each other's effect. This condition is basically called as the resonance in LCR circuit. Is this clear? Is this clear, guys?
Yes, sir.
So what is this frequency, by the way? At this particular thing, xc and xl are equal, right? That implies omega naught L is equals to 1 upon omega naught into C. Omega naught will go over here, it will become omega naught square, L will come down over here, and from here, can you see omega naught is equals to 1 by under root of LC? Yes or no? And from here, if I can write it as 2 pi into f naught, then can I write f naught will be equals to 1 by 2 pi under root LC? Yes or no? And if it is like this, can I say that time period is also 2 pi under root of LC? Is this clear, guys? So always remember, at this much frequency, the circuit will start resonating. Is this clear? लिख लो इतना, then we will discuss some graphs. Thank you, Bala. I think we can do this. Done, guys. Noting now. Done. So basically, guys, at f equals to f naught, which is equals to under root of 2 pi under root of LC. So at f equals to f naught, which is basically equal, this much, or basically at the condition of resonance. Can you tell me what all things will happen? I'm trying to write a summary, and in that summary we'll add some more points as well. So at the condition of resonance, what will happen? Z will be minimum. And what is the minimum value of Z? It is equals to R.
R.
The second point which will happen is basically I naught or IRMS will become
Maximum.
maximum. And what is this maximum value of I naught or this? This will be equals to I naught max will be Do you remember I naught is basically what? E naught by Z. I naught is basically E naught by Z, or IRMS is basically ERMS by Z, Z, right? But since we are writing the minimum possible values, and then this I naught or IRMS will become maximum, so I can write I naught maximum is basically what? E naught by Z minimum, right? And what is Z minimum? E naught by R. So this is the maximum possible value of peak current. And similarly, IRMS ka maximum value will be what? It will be ERMS by minimum Z, which will be equals to ERMS divided by R. Is this clear?
Yes, sir.
So I naught will be maximum. Can I draw a graph for this I naught? Can you see? I am trying to draw a graph in which I have on the y-axis. I am plotting basically, let's say, the maximum value of current at different frequencies, and on this side I am plotting frequency. So basically, this graph looks like this. Can you see at different values of omega, the maximum current which is coming is different, right? Sorry, at different values of current, at different values of omega, the values of this peak current is different, right? Yes or no, guys? At different values of omega, the value of peak current or RMS current is different. Can you see over here? Can you see over here? At one particular frequency, so at one particular frequency or one particular omega, which is equals to omega naught, the peak current becomes maximum of all the peak currents which is possible at different frequencies. So you can write the peak current is different at different frequencies, but out of all those peak currents, the maximum peak current occurs at omega equals to. Is this clear? At this side, the omega will be basically less than omega naught, and at this side, the omega will be greater than omega naught. Are you getting my point, guys? This is the region where the I'll try to write it with different colors so that you people don't get confused. In this region, the omega is less than omega naught. But basically, after this, can you see this whole region? Omega is less than omega naught, and in this region, omega is greater than omega naught. Whatever is after this. Is this clear, guys? Is this clear? I am not drawing the whole thing.
So this side it's omega naught is bigger than omega, right? In the right side.
On the right side, basically the frequency is less than the resonant frequency. On the right side, frequency is greater than resonant frequency. Left side, it is less. Right side, it's just like a graph. Can you see when you go towards 0, 1, 2, 3, something, something? So can you see if I get a place over it, this is 50 hertz. So 49 will come over here, 48 will come over here, right or wrong? So at this side, the frequency will be less than omega naught. Are you getting my point? And here it will be 51, 52, and so on. Yes or no, guys?
Yes, sir.
So, anyways, so this is the graph for current, right? Acha, by the way, when omega is less than omega naught at this particular instant, what will happen? Acha, we'll talk about it later, no problem. We know this particular thing now. Omega xc is equals to 1 upon omega c, and xl is equals to omega l, right? Yes or no, guys? Which point is it? Third point, right? So we know x is basically this and xl is basically this. So can you see this particular thing as omega increases, xl increases and xc decreases. ये सबको पता है by normal maths, है ना? Can you see denominator, numerator? If omega increases, then what will happen? XL will increase, XC will increase. So can you see over here? When frequency at this particular instant XC is equal to XL, right? At this particular frequency, XC and XL are equal. Now, if I talk about a frequency which is less than omega naught, that implies I have decreased the frequency. If I decrease the frequency, XL will decrease and XC will increase, right? Just the opposite of I written. If omega decreases, then XL will also decrease, but XC will increase, right? Yes or no? So at omega less than omega naught, XC will increase and XL will decrease from their values at omega equals to omega naught. Is this clear, guys? Whatever value which they had at omega equals to omega naught, since I am decreasing the frequency, then this thing will happen. If this thing will happen, so can I say XC will become more than XL? So XC will become more than XL. If XC becomes more than XL, that implies the circuit is having capacitive impedance. Or you can write this particular thing. The circuit impedance is capacitive. Okay. Similarly, when omega at omega greater than omega naught, xc will decrease and xl will increase from their values at omega equals to omega naught. Right? So at this particular instant, we can say this particular thing that XL becomes greater than XC, or you can say XC becomes less than XC. At this instant, the circuit impedance becomes inductive. Please write this thing. Then people, then
Yes, sir.
fourth point. Till now we have discussed 3 point what will happen at resonance. Fourth point, at this particular time the power consumed by the circuit will become maximum, and the circuit will be purely resistive, which I already told you, right? Circuit will become purely resistive. Is this clear?
Yes, sir.
What else? At this particular resonance, can I say the power factor, which is basically cos phi, will become 1. Do you remember at this particular instance, since xc and xl are equal, then tan phi will be equals to what? Xc minus xl divided by r. So this thing is 0, right? If tan phi is 0, then can you tell me what will be the value of cos phi? Will it be equals to 1, right? Yes or no? So from here we can say that the power factor at the resonant condition, it will be equal to 1, maximum power, right?
Yeah.
Acha, by the way, I told you about this particular thing that xc and xl will become equal, right?
Yeah.
Let's see what exactly this equal to. See, xc is equals to omega naught into xc was basically what? Omega naught into L. Oh, sorry. XL was equals to omega naught into L, and xc was equals to omega naught. Can anyone tell me? Omega naught into C, right? एक second. Guys, just give me 2 minutes. Now I'll be back.
Okay, sir.
So omega naught, we just calculated a little bit earlier. Omega naught was basically equals to what? 1 by under root of LC. So can I write this over here? If I write this over here, under root of LC into L, then can you see on solving this will become under root of L by C? And similarly, if this I'll solve, it will become 1 by under root of LC into C, which will be equals to under root of 1 upon, this will be 1 upon under root of C by L, and which will can be calculated as under root of L by C, right? So all, please remember this particular thing. At resonance condition, XC and XL both are equal, and this value is equals to under root of L by C. So you can write this as well. Done.
Yes, sir.
Huh. Just give me 2 minutes. Let me just change the name of my this pen tablet. So I think this is pretty much clear to you, right? Right. 7 point. We know that this.
Sir, what is that?
What is?
Like the last step?
The last step is basically I reverse this. Can you see 1 by under root of LC, and this will be C. When
So
it will
that
go,
is XP.
this is XC. Yes, sorry.
Okay, sir.
This is XI. So the last step is basically, can you see, do you remember the formula for average power was basically I square RMS into R? Yes or no? So if I try to calculate what is the power at omega equals to omega naught, then can you see the power will also become max, because I square RMS value is also changed, right? Yes or no? So at if I try to draw the graph again, the same graph which I drew for current. So this is, let's say, the maximum power. Oh, this is basically the power, average power, and these are your different omegas. So the graph will look like this. The graph will look similar to that of the current at one particular instant. Where will that instant come? At what particular frequency, guys? What is that frequency? Omega equals to omega naught. The average power dissipated will become maximum. Okay. So at one particular instant, the average power will become maximum. That is basically what? The angular frequency, the resonant frequency. Acha, there is, can you see over here? If this is the maximum power, I can choose this thing. Can I choose this particular point? Acha, please remember the graph on the left hand side and the right hand side shall be exactly same. It should not be like different, which we have drawn in this case. So the graph on left hand side and right hand side should be same. So there will be one point where there is this basically the power is half of the maximum power, right? So can you see this frequency omega equals to omega 1, and can you see this frequency omega equals to omega 2? So at omega equals to omega naught, the power is basically the maximum possible power. So there exist two frequency at omega equals to omega 1 and omega equals to omega 2, where the power is basically half of the maximum power. Is this clear?
Yeah.
At this particular time, the current also at omega equals to omega 1 and omega equals to omega 2, the RMS current will be basically the maximum current ka root 2 times. Sir, why? Because see over here, don't write this side, just write from here to here, don't write how exactly. So I square RMS into R, is this the power at this point? Will it be equals to P max by 2? So can I write I square RMS, that to maximum, or inside of I RMS to I RMS square, and this will become the maximum square into R divided by 2. R say R cut jayega, and can you see from here I RMS square, this is basically root 2 times of the maximum, right? So remember this particular thing, I'm talking about the current at when I try to draw this particular thing, no, the same graph, ye wala. If I try to draw the graph for current, I'm removing this. So at omega equals to omega 1 and omega equals to omega 2, the current is basically root omega equals to omega naught. This is basically I RMS maximum value, and at this particular instant the value of I RMS will be equals to what? I RMS maximum by. So this is what I meant by these 2 points. This omega 1 and omega 2 are important, है ना? So we'll see exactly what is this omega 1, omega 2. I'll take one more class, guys. One more class will be needed to complete the whole derivative, numericals, and the last thing is basically the transformer and the different losses in transformers, right? So one more class will be needed. So how many pages can you leave? 1, 2, 3, 4, 5, 6, 7. Guys, lose 6 complete pages, है ना? Even 6 pages छोड़ना है. You need to leave 6 pages. 6 में नहीं 5 छोड़ो तुम तो, because we'll at least do one derivation, है ना? So is this thing clear, guys? At omega equals to omega 1 and omega equals to omega 2, I RMS is basically what? The root 2 times 1 by root 2 times of the maximum RMS current. Anyways, please write the next heading, which is called as bandwidth of a resonance circuit. Bandwidth of a resonance circuit. What do you mean by bandwidth of a resonance circuit? Suppose if I try to draw the same graph but a little bit bigger. If you don't want to draw the graph, no need to draw the graph. So at this particular time, if I try to draw the current, this is basically what? Acha, please remember this is IRMS. I'm not writing IRMS, RMS again and again. I'm just writing I. है ना? So here I means what? IRMS only. Is this clear? People, is it clear?
Yeah.
Here I means what? IRMS value only. So IRMS I'm putting over here, and IRMS is maximum value is basically at omega equals to omega naught. Now can you see over here at this particular point at omega equals to omega 1 and omega equals to omega 2, this current, the maximum, the RMS value of current is basically root 2 times of the maximum, right? Yes or no? Yes or no? So we can say when IRMS is equals to the maximum ka root 2 times, then the power in the circuit is basically what? P max by 2, right? Yes or no? So can you see there will be a range of frequencies from here to here? There will be a range of frequency from here to here. Delta W will be basically what? W2 minus W1. This W2 will be bigger and W1 will be smaller. So can you see there is a range of frequency which exists from W1 to W2? This delta W is basically called as the bandwidth of a resonance circuit. So you can write the definition. The range of frequencies from W1, omega 1 to omega 2, where the power of the circuit is more than half the maximum possible power. And when is the maximum possible power, guys? The maximum possible power is at omega equals to omega naught. So is basically called as the bandwidth of resonance circuit. Is this clear? So basically this region where the current is basically this much, or the power is basically greater than half of the maximum power, is basically the region where we define is basically the region from omega 1 to omega 2, and this range of frequencies define it as what? The bandwidth. Is this clear? Shall we start calculating this particular thing, bandwidth? Guys, shall we start calculating this bandwidth? This is the derivation in your school. So now tell me this particular thing. When power is basically half of the maximum power, the current is basically, we know what is the current. The RMS current is basically what? Tell me. It is basically the root 2 times of the maximum this thing, right? I'll write it over here so that it doesn't get confused. So at P equals to P max by 2, IRMS is equals to IRMS maximum by 2, by root 2, sorry. Yes or no? ये तो सबको clear है? Is it clear, guys? Can anyone find what? Can I write this thing as ERMS divided by Z? Can I write this thing, because this is at general and this is at omega naught, right? Yes or no? This is general.
Yeah.
So this is at omega naught. So can I write this thing as what is the value of IRMS max? IRMS max will be basically what? ERMS by Z minimum. Yes or no? And can you see this 1 by root 2 time is all more there? So 1 by root 2 more. And what is the value of Z minimum? Guys, what is the value of Z minimum? R. So can I write this thing as ERMS divided by root 2 times of R? Can I write it like this? So can you see from here, E RMS by Z is basically equals to root 2 times of R. So can I say this particular thing that the impedance of the circuit is basically equals to root 2R? Can I say this?
Mm.
If I can say this particular thing, then this is true, then this is true, and if these are true, then this is also true. So समझ में आया यहाँ से यहाँ पे, and then we came over here. इतना समझ में आ गया? इतना समझ में आया guys?
Yeah.
So now from here, if I have any circuit, so can I write this thing as Z as under root of R square plus XC minus XL whole square is equals to root 2 times of R? Can I square the whole equation? If I square the whole equation, will it be equals to R square plus XC minus XL whole square is equal to 2 times of R square? 1 R square will get cancelled with 1 R square, and from there I'll have this equation XC minus XL whole square is equals to R square. And when I'll take the square root of this particular thing, can I write XC minus XL is equals to plus minus R? Can I write this? Is this clear? Can I write it like this, guys? Guys, hello.
Yes, sir.
खत्म नहीं हुआ derivation, अभी तो start हुआ है. This is the condition from where the derivation will begin. So now there will be two different cases. There will be case 1 when XC minus XL is equals to plus R, and there will be case 2 when XC minus XL is equals to minus R. Acha, by the way, please remember, if XC minus XL is positive quantity, that implies XC is greater than XL, and XC minus XL is a negative quantity, that implies XC is less than XL. So do you remember the two cases? Circuit is capacitive, circuit is inductive. So basically when I solve these values now, I'll get omega 1 and omega 2 indirectly, है ना? मतलब तो देखो, let's solve. So can I write this thing XC minus XL as, let's say, 1 upon omega 1 into C. And please remember, why am I writing 1 upon omega 1? Because can you see, when the circuit here on this side it was capacitive, right? And on this side it was inductive. So when I solve for this quantity, I'll solve for omega 1, and when I'll do for inductive, then second case I'll go for omega 2. So from here 1 minus omega 1 C into omega 1 L is equals to R, and from here 1 by omega 2 C minus 1 omega 2 into L is equals to minus R. Yes or no? Yes or no, guys? Ab, can you see here a quadratic will be found? Everyone can see a quadratic getting found. So 1 minus, guys, can you see over here, omega 1 into omega 1 is basically omega 1 square into LC is equals to R into C into omega 1, and here it will be 1 minus omega 2 square LC will be equals to minus of RC into omega 2. Can you see, guys? I'm solving simultaneously so that it won't lead to any confusion. I can rearrange this equation as, I'll shift this to the right hand side. So LC into omega 1 square plus RC into omega 1 minus 1 is equals to 0. This is your first quadratic equation. And similarly, LC on this side, omega 2 square minus of RC into omega 2 minus 1 is equals to 0. So can you see what is the only difference over here in the middle term, right? So there are two quadratics formed over here. When you solve this two quadratic, you'll apply the quadratic formula, right? Everyone remembers the quadratic formula, right? What is the quadratic formula? Minus of b plus minus b square minus 4a into c, right? So can you see this is minus, so it will become plus. So 4lc divided by 2a. So twice of lc. Yes or no, people? And similarly, when you will solve for omega 2, you will get minus of b. Can you see? This will become minus of minus plus, so rc plus minus under root of b square, r square c square, minus minus, so it will become again the same thing, 4lc divided by 2a, so 2lc. Is this clear till here? I am applying the quadratic formula, guys. Is it clear till here? And now it has two different values, right? Can you see, guys, two different values? One value will be with plus sign, and one value will be with minus sign. One value will be with plus sign, and one value will be with minus sign. Right or wrong? Right or wrong, guys?
Yes, sir.
But can you see over here in the under root thingy? The under root thingy, is it greater than RC? Can you see it is r square c square plus something ka under root? So this under root thingy will always be greater than RC, right?
Yes, sir.
Tell me this particular thing, when you take a positive sign, that implies this thing bigger is positive, smaller is negative. So ultimately your overall answer will be something, right?
Yes, sir.
And that will come in a positive quantity, which is acceptable. But when you take it negative, so the overall omega which will come will be coming negative. Is this acceptable? Is omega 1 acceptable? And negative,
No,
that
sir.
too negative. So can you see we have taken only positive values, right? So omega 1
Yes,
negative
sir.
is not possible, hence this is neglected. Similarly, can you see when you take a plus sign over here, again omega 1 will become positive, and when you take omega 2, when you take negative sign over here, so dekho, bigger thing has a negative sign, smaller thing has a positive sign, so this will come negative, right? So again this part is also neglected. So now you understood why are these two roots neglected of these two equations? Because the answer was giving us a negative quantity. Hence, when you solve this, and how will you write this thing in school exam? The negative signs will be neglected, and you'll get the final answer as minus RC divided by 2LC. C से C कट जाएगा तो minus R by 2L plus, this will be, in spite of solving it the whole, you can just write it minus of RC plus minus under root of R square C square plus 4LC divided by 2LC, and omega 2 will be equals to RC plus 1 plus under root of R square C square plus 4LC divided by. So only difference which comes is basically this RC sign, and this RC sign have the negative and has a positive sign. That's it. So when you calculate the bandwidth, which is basically omega 2 minus omega 1, so this minus that, when you do this minus that, so it will come to be how much? This में से ये कटेगा तो RC twice of RC by twice of LC. The final answer will be R. ठीक. चलो. So with this thing, I am done with the bandwidth. Next class will define the Q factor. We'll talk about the sharpness of an LCR series curve. We'll do some numericals based on resonance, and after that we'll do transformers, and we'll finish off with the chapter. Tomorrow, acha, how many pages do I need to leave? Guys, how many pages? 6 pages, right? 1, 2, 3, 4, 5, 6. Take. You have registers, no? Big registers. You can leave 6 pages, no problem. So with this thing, I'm done with this chapter. Okay, tomorrow, extra class. We'll see you tomorrow. We'll complete this thing.
This is J level stuff, right?
Yes. But this derivation is there in the school. People, some people ask me, sir, how will you do this derivation? I didn't understand. It's there in NCERT.
Okay.
Let's see you again, guys. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.